start the lecture. Let me recall you from lecture 1. When I say lecture 1, I meant lecture from trigonometry. An angle is in standard position. An angle is in standard position if its vertex located at the origin and the initial side extend along the positive x-axis. Now, how do I measure an angle? To measure an angle, you rotate, you start from the initial side, right here, and then rotate your angle all the way till the terminal side. So that's your angle. We call this angle, a lot of time we denote this theta. Because you guys remember, in lecture 1, we denote that one I highlight in black is what? What do we call it? We don't call it angle, we call it what? No, theta is angle. Arc length. And you confuse, like, to me, sometimes arc length is angles, sometimes it's not. And you are right. Because later I'll show you the formula where the association between arc length and angle, and you'll be clear, okay? If you want a positive angle, you're going to rotate counterclockwise. So going like that, you have a positive angle. Right? So for example, if I go pi half, so that's positive, theta equal pi half. If I would have gone the other way, then theta is negative pi half. A revolution is a complete rotation around a circle. So one rev is 2 pi, or another word, 360 degrees. Right, so one revolution, one rev, is equal to 360 degrees, or in radian mode is 2 pi. By the way, I know that when you guys took this class in high school and whatnot, you use degree a lot. And it makes sense to you, right? You see, if I say 90 degrees, you know what it looks like. If I say 60 degrees, you know what it looks like. But if I say pi over 3, you're like, what is that? Think of degree and radian is like metric system and in the system. When I first come to US, I have a trouble to visualize how long is 1 foot. I know how long is 1 meter, but because I was raised like that, metric system, right? So I got very confused with the English system. I still am, right? So same thing with you. Radian is foreign to you as opposed to degree. But unfortunately, calculus, they use all radian. They don't use degree at all. So we have to get used to it now. So drawing angle in standard position with a given measure. If I want you to draw an angle of 270 degrees, you start from the x-axis, right here, the initial side, right? And you go counterclockwise because it's a positive angle. Right there. That's theta equals 270 degrees. If I want negative 270 degrees, you're still starting at the x-axis, but you go clockwise. Like that. The 360 degrees, that's one surround. That's one surround. You guys try D, E, F. That's easy enough. Negative 90 degrees, you always start the x-axis. Like that. 90 degrees, counterclockwise, like that. And negative 180. So you get the idea of negative angle and positive angle now. Now, if you notice about the terminal size of angle in part A and part D, this and this, what do you see? What happened? You end up in the same what? Terminal side, right? So they end up, so I'm gonna write out. They end up on the same so that no, it's just that. And same thing for part B and part E. They end up on the same terminal side, even though they rotated in different directions. Right? And we call those, even though you rotate differently, but you end up on in the same terminal side, we call those coterminal angles. So coterminal angles are angles are coterminal if they share the same initial side and terminal side. But I don't know how you go. I don't know what direction you go, but you start at the same side, you end up at the same side. So they are coterminal. Coterminal angles always differ by a full rotation. So that means if I have the angle theta, then theta plus 360 degree is the same thing as angle theta, right? Let me show you visually. Say I have a unit circle like that. I want to go 90 degree like that. It is the same thing as I do this. It's the same thing as I go once around the circle at 90 degree more, right? So the green one, the blue one is 90 degree. The red one is 90 degree plus 360 degree, which is the same thing, right? A lot of time we just kind of ignore that once around, right? If you go twice around, you end up in the same terminal. You three times around, it's the same thing, right? So a lot of time we ignore the number of times you go around the circle. So from the picture, I can conclude that 90 degree is the same thing as 90 degree plus 306. You know, let me use radian so you get used to it. 2 pi times k. 2 pi is the same thing as 360 degrees. K is the integer. 1, 2, 3, 4, 5. The number of times you go around the circle. Where k is the set of integer. So here is a unit circle. There's another piece, another sheet that I think you're supposed to be given on, forgot what lecture 24, 20, 23, 23. I don't know if you noticed that. I'll put it up again in the future. But you're supposed to fill that out. You're supposed to fill out the angle. You're supposed to fill out what is the point at that angle. So for example, here, right here, what is the point? 1/2 for x, right? I never remember, but that's how I do it. Either 1/2 or √3/2, right? 1/2 for x, and then the other one is gonna be √3/2. And then just from that one thing, I just kind of construct the whole thing, right? Because they're symmetric. All right, let's familiarize ourselves with radian measure. Recall the circumference of a circle, radius r is given by c equal 2 pi r. If the radius is 1, then you have a unit circle. Then the circumference is just 2 pi. A complete revolution, which is 360 degrees, has a measure of 2 pi radian. So if you take a look at this circle right here, 1 pi will be half of a circle. 2 pi will be the whole circle. A quarter of a circle will be pi half radian, right? Now, what about 1 radian? If I say 1 radian, people even confuse even further. One pi is equivalent to how much? 3.1415, etc. Right? So 1 pi, use black. 1 pi is half a circle. So roughly it's divided half a circle roughly into how many equal parts? 3, right? So I have 1 radian right there. Let me use red again. 2, and then 3, right? So here another 1 red. Here's another one. Oh. Here's another 1 red, and that little itty bit is 0.1415, etc. radian. You can imagine. Can you imagine it now, right? One pi is 3.1415 radian. Well, if I ask you what is 1 radian, you kind of divide this half a circle into approximately 3 equal parts. Leave a little bit for the decimals, right? 1 radian, 2 radian, 3 radian. So that's how you imagine radian. 1 radian is roughly 57.3 degrees. It's not like you have to remember that. 2 radian, you double that, so 114.6 degrees. Again, you are not supposed to remember that. It's just the FYI. In trig problem, a lot of time you are asked to convert between radian and degree. So let's do that now. I'll jump to 3b because it's the same thing that they explained above there. I want to convert 140 degrees to radian. Now, this is elementary math. Do you guys remember how to convert unit, right? You want to cancel something and want to keep something. I want to cancel degree. So degree is going to be in the bottom because I want to cancel those 2 units, right? I want it to be radian. So radian on the top. 180 degrees is equivalent to pi radian, right? I'm gonna use black for that one. So far, so good. So basically, I multiply this expression by what? By 1. I didn't change. 1 pi is equal to 180 degrees. Can you cancel the degree? Yeah, you can cancel the degree now. Right? You cancel that little degree. 140 over 180 is equivalent to, if you simplify that, it would be 7 over 9 pi red. So the only unit left is radian. Why don't you try C? Try C first. We'll do B next. Yeah, try C. What do you have? Anybody have an answer? Very good, right? So 10 degree multiply with, again, you want to cancel the degree, so degree is going to be in the bottom. Pi red equal pi over 18 radian. Convert radian, now convert radian to degree. Oh, that's supposed to be your U. Oh, sorry. That's supposed to be your U try one, I think. Let's just do that. Pi over 6. So this is radian. I want to cancel radian. So radian is going to be in the bottom. Now pi radian in the bottom, 180 degree on the top. Radian cancel. Now only the unit cancel. You're not canceling pi 6. Well, you can cancel one of the pi, but you don't cancel the 6. That and that. 180 divided by 6 is 30 degrees. I don't remember which one is your U try one. I put it E. I put it E in my note, but I think I changed my mind during when I don't remember what I did. Let's just do all of them. Pi over 4 times 180 degree over pi rad. When I check, I'll let you know. Oops, let me put the red here. Pi rad cancel. 180 degree divided by 4 is 45. The U try is C. I don't remember. I'll let you know. We come back to coterminal angles. Like I said, coterminal angle is differs by a full rotation. So if I ask you to find the coterminal of pi third, then for the positive angle, you add to 2 pi. For the negative angle, you subtract 2 pi. That's all it is. It makes sense, right? If it pi third, if you want to go pi in positive direction, you add another once around, right, which is 2 pi. If you want to do negative angle, then you go backward. So you go backward 2 pi. Let's do number 5. They want you to find the positive and negative angle coterminal with negative 5 pi over 4. So let's do the positive one first. Positive angle right there. That's your formula, right? Whatever angle they give you, add to 2 pi. So negative 5 pi over 4 plus 2 pi is the same thing as negative 5 pi over 4 plus 4 pi, 8 pi over 2, right? Over 4, I'm sorry, 8 pi over 4. Negative 5 pi plus 8 pi, that's 3 pi over 4. Negative angle. Subtract 2 pi. So negative 5, negative 8, that's negative 13. By the way, negative 13 pi over 4 is the same thing as what angle? Critical thinking. I didn't teach you this, but if some of you are smart enough, this is equivalent to what? Negative 5 over 4, right? Don't write this down. This one is equivalent to negative 12 pi over 4 minus pi over 4, right? What's negative? 3 pi. No, it's actually It's not negative pi over 4, my bad. It's actually this. So you go 3 pi surround 1, 2, 3. You end up here, and then you add an. I went counterclock. It should be clockwise. A negative 2 pi, negative 3 pi, and then another pi over 4. So it's right there. It's right there. All right, let me show you how. Let me check my answer. I at least check the positive angle. I wonder if I can. My answer is what? My answer is 3 pi over 4. Is negative 5 pi over 4 equal to 3 pi over 4? Let's check. Negative 5 pi over 4. Now let's start with positive 5 pi over 4. Positive 5 pi over 4 is right there. If I want negative 5 pi over 4, I have to go what? Clockwise, right? I go like this. And end up right here. Does that make sense? Does that make sense? Right? Look at that. Negative 5 pi over 4 is the same thing as 3 pi over 4. Right? So that's what we did. We can check with the other one too, but I don't have time. So, but long story short, to find the positive angle, you add 2 pi. Negative angle, you subtract 2 pi. Number 6, they asked you to determine whether angle 70 degree and 430 degree are coterminal. Let me give you a little note. To determine two angles are coterminal. We take smaller angle and add to 360 degree times k or 2 pi k, right? Where k equal 1, 2, 3, etc. Because that's what we did, right? That's what we did. We add 2 pi, but sometimes it can go more than once around, right? You could go twice around, 4 times around, 6 times around. All right, so I want to know if a 70 is a coterminal with 430. Let's start with, according to the note, I'm going to start with k is 1. First, right? Start with k with 1. You work your way up if you don't get your result. 70 degree plus 360. Why don't I use 2 pi? Because my original unit is degree. Well, 360 times 1 is 360, which is equal to what? 430 degree, right? So your answer is yes. Answer is yes. You can check another way around. You wanted to, you can do one more time. You can take 40, you take the larger angle, subtract what? 360 degree, right? When you find the negative angles, just 70 degree. But let's just do one of them. Number 7, the same thing, but here we use radian. Which one's smaller, 22 pi over 3 or 11 pi over 3? Which one's smaller? Oh, which one's smaller? 11, I hope so. 11, right? Don't think, you can ignore pi. Pi is the same everywhere, right? 22/3 is bigger than 11/3. Same deal, right? Start with K for 1. So I have 11 pi/3 because it's smaller angle plus 2 pi. You don't want to use 360 degree, right? Because we start out with radian. 2 pi times 1. Just 11 pi/3 plus 2 pi is the same thing as 6 pi/3, right? So that's 17 pi/3. It's still smaller than 22 pi/3. So I'm gonna keep going, right? If it's smaller, then you keep going until if it equal or past it, you stop and then you conclude. So 11 pi/3 plus 2 pi times 2 now. K is 2 now. Eleven pi/3 plus 4 pi. 4 pi is the same thing as 12 pi/3. You end up with 23 pi/3. You go over it. So you kind of go past it, right? So you stop. Well, what do you conclude? Not a coterminal, right? They're not equal. Do you have any questions so far? It's a good time to ask questions. Yes. Five. Mm-hmm. You asking for 5 or 6?
I'm saying that could you do the same thing for 4 and 5 as you did for 7?
No. There's two different things. Number 5, they asked you to find the coterminal. Number 6 and 7, they already gave you the coterminal. They just want you to prove whether they are coterminal or not. 5 is different than 6 and 7, okay? Different. All right. Here I say I go back to angle and arc length. You got confused about angle and arc length. Now, arc length is a fraction of a circumference. Circumference, right? Circumference is 2 pi r. So S equal theta divided by 2 pi times c. So if I take c times the fraction of theta divided by 2 pi, that's my arc length. And then they substitute c here as 2 pi r, cancel some stuff, cancel 2 pi. So S is end up equal to pi theta times r, where theta is your angle. Now, when is arc length is the same thing as angle? When r equal what? 1, right? When you have a unit circle, arc length and angle are the same thing. But because in the first 2 lecture, we're not allowed to call that is angle because the circle you given doesn't have to be of unit 1 all the time, right? So when the radius is 1, arc length and theta are the same thing. If the radius is not 1, they are 2 different things because of this formula. So I hope it's kind of cleared out for you what's arc length and what's angle is about. So that right there, you study in lecture 1 and 2, you call that arc length, right? T, you call that T, can I remember that, T? By the way, theta always calculate as radian in this formula, or any formula we speak in forward from now on, okay? Always in radian. If I give you degree, you change the radian before you do anything else. Central angle theta in a circle of radius 5 and arc length 10 inches is shown below. So I know my arc length is 10. That means S is 10. That's equal S. S is 10. Radius is 5. That's R. They want you to find theta. So plug in your formula. S is 3, R is 5. Theta is the one you're looking for. So theta equal, oh sorry, S is 10. I don't know why I say 3. S is 10. Theta equal 10 divided by 5, which is 2 radian. Makes sense? Look like 2 radian to you? Remember how I show you to divide half an angle into roughly 3 radian, right? So it is look like 2 radians. Use definition to 1 radian to 5 theta. I don't know why. I think this is kind of dumb. If you ask me. So that is 1 radian. That right there is 1 radian. But let's just do what they want. This is on another 1 radian. So we know that 1 radian equivalent to my arc length is, what is it, 5, right? So 2 radian equivalent to my arc length is 10, and we're done. I'm not sure that's very important on the exam, but number 9, they want you to find the arc length S, given radius and angle. That's 100 and okay, hang on. I see something funny. The angle they give you, this right here is 140 degree. So this will be what? 360 minus 140, right? That's the one we want, right? Tricky, huh? So the angle that we want is 360 degrees, subtract 140 degrees. Because the arc length is that way. Which is equal to what? 220? Thank you, 220. Do I stop here and then start the formula, or do I have to do something else? Convert, right? Convert to radian. So theta equal 220 degree times. Again, you want to eliminate the degree and you want radian. So pi over 180 degrees. And then so 11 over 9, right? Now you can start the formula. S equal R times theta. R is 5, theta is 11 pi over 9. 55 pi over 9 radian. Number 10. I win. I keep having a second thought, so now I'm confused. I don't know which one is mine. You try. Today is the 2020. You try to double check. Okay. I did your you try too. I think you got freebie today. I had the second thought. I know in my note is the number 10, but I remember I have a second thought because number 10 is harder. I don't want to give it to you. All right, we do number 10. Let me tell you number 1. You try number 1 as well. You try number 1 is C. I knew it's C. You try. All right, continue, number 10, let's do number 10. It was your original you try, but I changed my mind. If a weight hanging on a string length 3 feet. So from here to here, that's 3 feet. Swing through a 5-degree on either side of a vertical, 5-degree on either side. So each of these is 5 degrees. So theta equal 5 degrees. So the whole thing will be what? The whole thing will be 10 degrees. I shouldn't call that theta. Just put 5 there. So how long is the arc through which the wave move from one high point to the next high point, round to the nearest 100? So they want you to calculate this, the arc right there. That's S. Given the angle is 10 degrees. So given theta equal 10 degrees, you're going to change it into radian. Should be pro by now. Pi over 18 radian. Now you calculate S. S is R times theta. R is 3, right? Times pi over 18, pi over 6. Unit will be, they didn't give you unit. Oh, they want you to round it to pi over 6. Pi divided by 6.52. Because they don't give you units, I'm gonna say just units. It could be meter, it could be feet. Oh, this is feet. They did give you units, sorry. Feet. .52. So far, what we learned about the formula of the arc length, right? Next, formula of a sector area. Right? Area of a circle. We know that is pi r squared. We multiplied the area with theta divided by 2 pi like we did earlier. Simplify pi in the pi. So I have 1/2 r squared theta, and that is the formula for the area of a sector of a circle. So instead of calculating the area of a whole circle, we just want a little bit of a piece right there, right? So now next time you can calculate what is the area in your piece. So here is the formula. Let's do this one. An irrigation system use a straight sprinkler pipe 300 feet, right there, 300 feet long that pivot around the central point as shown. Because of the obstacle, the pipe is allowed to pivot through 280 degree only. Find the area irrigated by this system. Approximate your answer to the nearest whole number. All right, so I want to find the area of the green area right there, the one in green. My formula is A equal 1/2 R squared theta. Theta has to be in radian. Why don't you change theta to radian for me? That's your first step. Go ahead and do it. (14 pi/9). And now you can apply the formula. A equal 1/2 R squared theta. 1/2 times 300 square. Theta is 14 pi/9. Let me give you a happy ending. It's 70,000 pi. What is my unit? Feet what? Square feet, right? You can approximate that yourself. It's not too bad. Okay? Number 12. Number 12. The top and the bottom end of a windshield wiper blade are 34" and 40 inches. That one is 34, and this one is 14. While operation, the wiper sweep through 335 degrees. Find the area swept by the blade. So they want what? Which one? They want this area right here. Let me use blue. They want that area. Before I do anything, let me remind you, don't write this down. If I have a function, say a red function and a blue function, I want to find the length between those two functions. And usually I do this. In math, we do this. We take a longer function, subtract what? A shorter function, and we get the one in between, right? That's what we do, right? We do the same thing here. We take a larger area, a fan one. We take the larger area, subtract the smaller one, we get the one in the middle. Right? So you have to calculate your area twice. So A1. By the way, before we do that, we have to do what? Change, right? It's very easy to forget. which is I'll just leave it like that. I don't care. 135 over 180 pi. You can simplify, but you're wasting your time. You simplify at the end, right? It's not your final answer. So A1 equal 1/2 R1 square times theta. R1 is 34 inches square. Time theta is 135 pi over 180. Your answer is roughly 1,361.88 units will be square inches. And for the smaller one, the little area, 1/2 times R2 squared times theta. R2 is 14, so 14 squared times theta, which is 135 pi over 180. 230.91 square inches. The area that we want is the one in between. So we take the larger area, subtract the smaller area. And I'm going to round it into the nearest whole number. So, well, let me give you the decimal first. 1130.97. So this is equivalent to 1131. $15 is your, you try. I'm going to do number 16, which is very similar. You try 3. At least this one you do on your own. I did 2 of them for you. All right, let's do number 13, just a little bit. Oh, I'm gonna talk to you about linear and angular speed. By the way, if I don't have time, once you leave, I'm gonna record the number 16 for you, okay? So that you can do number 15. Does that make sense? It's exactly the same thing. The only thing different is that number 16 is given diameter. I have to convert this into radius. For you don't have to do anything. Right? Radius is given. You don't have to divide it by 2. Okay, that's the only thing different. The rest is the same. All right. Linear speed and angular speed. Linear speed is the distance traveled divided by time. Pretty much, you go from your home to OU to your home. That's linear speed. Right? I mean, distance divided by time. Now, angular speed is the speed of your wheels, your cars. That's angular speed. So you guys distinguish between the two. Linear speed and angular speed. Angular speed denote omega. It's not W. That's little Greek letter. That's omega equal theta divided by time. Where linear speed like that. So let me write here. I have V equal S divided by T, and I have omega equal theta divided by T. Now, if I substitute, if I start out with V equal S divided by T like this, and I substitute S with R times theta. So that's my S. Now it's R times theta. then it's equal to R times theta divided by T. Well, what theta divided by T? That's angular speed, right? Which is R divided by R times omega. So let me write out something here. So from the two, I can come up with another formula, which is V equal R times omega, another formula for linear speed. And when do I use this formula? The black formula, V in black, is not the same V as above, right? V in black is the association between the linear speed and the angular speed. Let me give you an example. Let me do number 13, I'll let you go. And then for 14 and 16, I'll record it once you guys left. You guys leave, all right? Convert 125 revolution to radian. 125 rev times, remember you want radian, right? One revolution is equal to how many radian? Radian. 2 pi, right? 2 pi, thank you. So one rev, put one rev in the bottom because you want to cancel with the rev in the top. 2 pi radian. Revolution, cancel. So we have 250 equals 250 pi radian. It's kind of like changing between degree and radian. Number 14, a radio saw had a blade with a 6-inch radius. Suppose the blade spin at 1,000 revolutions per minute. Find the angular speed of the blade in radian per minute. Right, so angular speed, again, let me write out the formula, is omega equal theta divided by T, where theta has to be in radian. Right, so first thing first, we're gonna change 1,000 revolution per minute into radian. Let me put it down here, 1,000 rev per minute. T is 1 minute, right? T is 1 minute. So I need to change revolution to radian. So times rev in the bottom, one revolution is 2 pi radian. Now revolution cancel, right? Now we have 2,000 pi radian per minute. And that will be your omega. That will be your angular speed. Now we want to find the linear speed of a saw T in feet per second. So the linear speed that associated with the angular speed is V equal R times omega. Well, we have omega, we have R. R is 6 feet. All we have to do is plug it in. So equal 6 times omega is 2,000 pi. Let me put in units. Okay, I like to put in units so I can see 2,000 pi radian per minute. So this is equivalent to 6 times 2,000 is 12,000 pi. And the unit will be feet per minute. Now we want feet per second, not minute. So we need to convert the minute into second. We do the same thing, right? Units changing, same thing. So 1 minute equal to 60 seconds. Make sure you put the minute on the top so it cancel with the red one on the bottom. That cancel. 12,000 divided by 60 is 200 pi feet per second. Number 16 is very much similar to numbers 15. You try. The only thing I have to do extra for my problem is that I have to change the diameter of a bite, of a woman bite here is the given diameter. We want radius, right? So that 26 inches diameter is equivalent to 13 inches in radius. If the wheel rotates 225 revolutions per minute, find the speed at which she's traveling in mile per hour. So first, find the angular speed in radian per minute. It's pretty much similar to number 14. Number 14, they kind of break it up into two parts for you, where number 16, they don't do that, right? They just kind of ask you the ultimate question. But if in terms of showing the work, it is two parts. Right? So first we find the angular speed, which is omega equal, a given omega is 125 revolution per minute. This right here, that's your omega. But in revolution, right, we need to change it to radian. So 125 rev per minute, change it into radian. 1 revolution equivalent to 2 pi radian. Which is 250 pi radian per minute. Now we have the angular speed. We can calculate the linear speed, right? So now we use black. Now the linear speed v equal r times omega. You cannot use s divided by t. You don't have s, right? You remember the one in blue right here. There are two of them. Well, use the one that you have. We don't have s, right? But we have r and omega, so we're gonna use v equal r times omega. Well, r is radius, which is 13. Omega 13 inch. Omega is 250 pi radian per minute. I like to include my units. Why? Because later I need to cancel something. Right? That's equivalent to 3,250 pi inch per minute. Right? Now the thing here is they don't want inches per minute. They want what? Mile per hour. Right? So we have to change that into mile per hour. We're gonna do this one step at a time. We know that we're gonna change from inch to feet and feet to mile. Let me give you some information. 1 foot equivalent to 12 inches. 1 mile equivalent to 5,280 feet. I bet you don't have that on top of your mind. So first, I'm going to change inches to feet. 1 foot equivalent to 12 inches. I want to cancel inches, so that should be in the bottom. Right, so inches cancel. Now I have my unit is feet over minute. I'm going to convert feet into mile. One mile, so feet in the bottom here, and mile on the top. 1 mile is 5,280 feet. Now you can cancel what? feet and feet here, what you have is mile per minute. We almost there. All we have to do is change minute into hours. And that's easy, right? 1 hour is equivalent to 60 minutes. So multiply. I'm running out of space here. Let me move it to the left a little bit. Like that. We want to cancel minute, so minute gonna be on the top. An hour here. 1 hour is 60 minutes. So now I can cancel the minutes here with the minutes here. Right, we cancel pretty much everything. Now what would we have? We have mile per hour. Right, we're good. We can stop here. All we have to do now is multiply all the number across. When you do that, 3,250 pi times 1 times 60 divided by 12 times 5,280, you got 3.07 pi mile per hour, or equivalently to what, 9.6 mile per hour. And that will be your final answer. Number 15 is exactly same as number 16. You should be able to mimic what I just did.